So I'm going to show you how this ties in, completing the square ties in to other expressions. So if we have x squared plus 8x, that's like having a rectangle that is x times x plus 8, which is split into this, or a square where we have x plus 4 and x plus 4. So it's the same as x plus 4 squared. Now notice the link here between the 8 and the 4. Think about what we had to do to get 4 there specifically. So then we have x squared, 4x, 4x. So we have x squared plus 8x there, but we have this extra 16 that we don't need. So we have x squared, x plus 4 all squared, take away 16 to get our x squared plus 8x. Okay, and those are identical, so I'm going to call that an identity. So if I was to complete the square then and rewrite them, I would write this as x plus 4 squared. Remember that we had to halve that 6 to get the 3, so we halved the 8 here to get that 4. But then when we do that, we have this extra bit here that we don't need. So we take, and that is equal to your 3 times 3. So in our case, it's going to be the 4 times 4, which is 16. So we get rid of that 16. So x squared plus 8x is the same as, or identical to, x plus 4 squared, take away 16. X squared plus 2x. Following the same pattern then, that's going to be identical to x plus 1 squared. So that's going to give us x squared plus 1x plus 1x, but it's going to give us an extra plus 1, which we don't need. So we take away 1 at the end. Then we have x squared plus 10x. Well, that is identical to, well, if we halve the 10, split the 10 between those two sides, it's going to be x plus 5 squared. X plus 5 times x plus 5. That's going to give us our 10x and our 5x and our 5x to make 10x. But it's also going to give us an extra 25 here, so we need to get rid of that 25 to leave us with just the x squared plus 10x. 4x squared plus 12x, that's an interesting one. 4x squared plus 12x. If you were to draw the diagram for that, then it makes sense to say we're going to have 2x here and here, but we don't want 3, we don't want 6, we don't want just the half of the x this time. If we want 2x squared, 4x squared there, but we want 12x altogether. So what we do want 6x here and 6x here, but that means we want 3 here and 3 here. So what we end up with being identical to is 2x plus 3 squared. But then we have a plus 9 here that we want to get rid of. So we have that 9. So if we don't have 1x squared, it becomes rather different, but we can still do this using our grid here. So our 4x squared, we still want 6x and 6x, but that means we have a 3 here instead of a 6 because we have 2 x's here this time. All right. So the general rule then for completing the square is the number here is going to be half of this number here, unless we have that. If we have that, we need to halve that to get the number of x's, so 2 x's. And then half of this thing is divided by that number. So half of the 12 was 6, and that gets divided by the 2 to give us the 3 here. All right. There's another way of handling it. If we had 4x squared plus 12x, we could handle it in a slightly different way. We could take 4 out as a factor. This is equivalent to 4 lots of x x squared plus 3x. And then we could complete the square with this x squared plus 3x is identical to 4 lots of, and then if we complete the square inside those brackets, we've got x plus 1.5 squared, take away our 1.5 squared, because that 1.5 times 1.5 would be our part here. So 1.5 is 3 over 2, so 3 over 2 squared is 9 over 4. And then we just have to multiply everything out by that 4. So 4 lots of this bracket. And then 4 lots of negative 9 over 4, which is minus 9. And we could then put that 4 into our bracket. So 4 is 2 squared. And then you can see we have, at that point, two things multiplied together that have the same power. So we can just multiply the two together. So 2 times x gives us our 2x. 2 times 1.5 gives us our 3. And the squared stays the same. We have, that's one of the lesser known index laws, where you have a to the power of n times b to the power of n. Altogether is ab to the power of n. All right. So to write this out formally then, if we were to have x squared plus 8x, completing the square, that is the same as asking us to have it in this form. You'll often see questions not say complete the square, you'll say rewrite this in this form, all right, or give this in this form. And generally the form is something x plus a squared in bracket, x plus a in brackets squared, and then plus or minus b. And how we do that is, like we've said, to halve the coefficient of x, so 8 divided by 2 in this case is 4, and place that 4 into the square, into the bracket, so x plus 4 squared. And then we'd have to expand the brackets to calculate how you need to adjust it, or in other words, you could just recognize that we have the 4 times 4 at the end to give us 16. So we need to subtract 16. So x plus 4 all squared take away 16 is the same as x squared plus 8x. In other words, we just have to square this and take it away. Another example then, x squared plus 6x. Again, we can halve the coefficient to get x plus 3 squared. Should be able to then figure out exactly what we need to subtract. And if you've figured that out, well done. We're going to end up subtracting 9, because if we expanded these brackets, we've got plus 9 at the end, which we don't need. So we get x plus 3 all squared take away 9. That is the same as x squared plus 6x. Do another one. X squared plus 10x. Half the coefficient to get x plus 5 squared. The 5 squared is what's left at the end when we expand that bracket or have it in our square. So we need to take 25 away. To get x plus 5 all squared, take away 25 is the same as x squared plus 10x. And we could keep going. Another example here for you, if you need them. Now, taking away is interesting. Taking away is a bit different. We still have the coefficient, but the coefficient is negative 2 this time, so it's x minus 2 all squared. So really we should say is this is negative 4 divided by 2, so it's negative 2. And if we expanded that, you can see we'd get x squared minus 4x plus 4. So even though the number inside the bracket here has become negative, our number here doesn't become positive, it stays negative. We still end up having to take away that 4 from our original expression here. So we still have x minus 2 all squared take away that 2 squared. X squared minus 12x then. Have a go at that one and then continue watching the video. Okay, so when we do this, we've got 12 divided by 2 to get 6, or negative 12 divided by 2 is negative 6. So we have x minus 6 all squared. If you expanded that, you've got plus 36. So it's x minus 6 all squared, take away 36 to give us our original x squared minus 12x. All right, your turn. Have a go at this one. So with this question, we should end up with x plus 7 all squared, which gives us x plus 7 squared, take away 49 to give us, which is equal to x squared plus 14x. Have a go at this one. So if we halve the coefficient, we've got x minus 4 all squared, and then we're going to have to take away the 16 that it produces to get x minus 4 squared, take away 16.